Hi everyone. For today's concept presentation, I am going to be deriving the Michaelis-Menten equation. I did attach my file with all the steps. I tried to attach the audio. I don't think it went through, so this is just in case, a little extra. So step by step is how I did it. So first off, here we're going to assume a reaction equation in which the enzyme and substrate bind reversibly and then go to form the product. And so we're going to assume an initial reaction, so there is very little product making the second back reaction. So here we got E plus S with K1 and then a K minus 1 with ES and then K2 with a E plus P. So let me zoom in on my 3. Here we got K1 is a rate constant of forward first. Then we got K minus 1 is a rate constant of backward first. And then we got K2 is a rate constant of the second step. I am hoping this is semi-legible, not too backwards for you. I apologize if it is, but like I said, I attached my actual document, so you should be able to follow with that. So now we are on step 2. Okay, so here the initial state is going to be VO of the reaction, which is going to be VO equals K2 multiplied by ES. So I'm going to revert back to this one because this is going to be known as our first equation, in which we will be using later on in the upcoming steps. So then we're going to go down to step 3. And so here, the thing here is we actually don't know what ES is since it's forming during the reaction. However, we can make the steady state assumption that it will have a low concentration that will not change, since the rate of its formation is going to equal to the rate of its breakdown. Hence, here we got a equation of K1 multiplied by E multiplied by S equals K negative 1 multiplied by ES plus K2 multiplied by ES, known as our second equation, in which we will be going back to later on. So I would just note that. So here we are on step 4 now. So here we also don't know what our E enzyme value is, in which E is also known as the concentration of free enzyme. Because of the enzyme is bound, we know that the free and bound enzyme is going to be equal to the total enzyme concentration, with a equation leaving us with ET equals E plus ES. So now we're going to go down to step 5. So now we're actually going to substitute the total enzyme into the steady state equation 2, which is what we saw in step 3. Okay. Back to step 5. So with that being said, so we're going to use the equation 2, and what we're going to do is we're going to rearrange and solve for ES. And so that equation is going to be followed by a K1 multiplied by ET minus ES multiplied by S equals K negative 1 multiplied by ES plus K2 multiplied by ES. And so the K1 is then going to be simplified. Then that equation is going to be simplified to a K1 multiplied by ET multiplied by S equals K1 multiplied by S plus K negative 1 plus K2 multiplied by ES. And that is going to be simplified down into ES equals K1 multiplied by ET multiplied by S divided by K negative 1 plus K2 plus K1 multiplied by S. So now we're going on to step 6. where we're also going to do some rearranging in this expression to isolate the rate of constant, and then we're going to replace the constant with a new constant, and that is going to be referred to as the Michaelis constant, known as Km. So here we got ES equals ET multiplied by S over K negative 1 plus K2 divided by K1 plus S. Simplified down to ES equals ET multiplied by S divided by Km plus S. Therefore, Km equals K negative 1 plus K2 over K1. Okay, down to 7. So Km is the Michaelis constant. Just another repetitive reminder. So 7, here we're going to do some substituting, and we're going to substitute the value of ES into the rate equation given by equation 1. And so K2 can also be called the catalytic constant or Kcat because it does represent the rate constant from this reaction. So here it's going to be the VO initial equals K2 multiplied by ET multiplied by S over Km plus S equals the Kcat multiplied by ET multiplied by S divided by Km plus S. So that's our step 7. And last but not least, we got the maximum velocity. So here Vmax is equal to the total enzyme concentration times the catalytic constant, substituting Vmax into the equation to get the final form of the Michaelis-Menten equation, giving us a VO equals Vmax multiplied by S divided by Km plus S. Therefore, Vmax equals Kcat multiplied by ET. Awesome. Thank you.